Hi guys, let's have a look at question number 8 in Sepsim. Let's see that how to complete that. Okay, so I open my virtual machine here and the question paper on the right side, which is the lib task 8. So complete the following task before participating for the lib viva. So what is the question now? A, B, and C are three positive integer numbers. So make sure that this positive integer numbers and store at locations 80 and 81 and 82. So initially we have to save three positive numbers to the accumulator and then retrieve them and compare them which one is bigger. That's very simple actually. So now I'm going to open the Sepsim beta here, right? I'm going to maximize this and simulation, initialize simulations, and you have to choose a processor type. I'm going to choose IL, and then this should be accumulator, right? Now I'm going to start editing my file, launch program editor. Either you edit it or you're going to create a new one, right? So initially, let's see that there are A, B, and C. So you just decide what number you like to put. For example, I want to put 7, 8, and 9. I'm going to compare this line for the initially. So let's comment this line numbers. We know that we are going to put 7, 8, and 9. Right. So I'm going to store this number 7 to the location 80, 8 to the location 81, and 9 to the location 82. I'm going to say load ACC. So I'm loading this specific number 7. Now the value in the accumulator is 7. Okay, so I don't need this. I'm going to delete that. Okay, so the value in the accumulator now is number 7. So now I won't store this number 7 to the address, because the thing is we have to take that value from the address and you have to compare it. But initially when you start the program, there are no values in the address. So I'm going to load this number to the accumulator and I'm going to save it. So how to save it now? Store ACC to address. I'm going to save it to this address 0x80. So I'm going to save it now. So I saved the first number to the location. Now I'm going to do the second number. So the same thing now. Load the second number to the accumulator, which is load ACC, and what number? Let's say 8, for example, for instance, 8. Now we are going to store ACC to the location, new location. What is that? The location is 81, x81. So in this case, what will happen? First case, it's loading number 7 to the accumulator and storing in this address. That is finished. So after you store, still the accumulator has number 7. That's why we are replacing with this one, say load ACC number 8 mean now the number 8 will be loaded to the accumulator. Now I'm saving that value which is in the accumulator. Now I'm storing to address 81. So I'm going to do the third step, which is very easier. Same thing, load ACC, and again I'm going to load number 9 and then store ACC. I'm saving to x82. So for the meantime, but we completed, it's already okay. Save your file. I'm saving it. We will not continue everything now. We will save it first and we will see whether it's really saving these numbers in this address. Okay, I'm going to save it now. In the desktop, I'm going to say lab 08. Okay, then saving this and then check your code whether you have any mistakes. Check it. Syntax check successful and build it. And when you build, it's showing to here build succeeded 0 errors 0 warning. So far everything is all right. Now I'm going to load this program and run it. Right. I finish editing this program. I close it. I go to the simulation, load program, and showing me in the desktop that this lab08 file. I load it now. I open it. Now you can see the loaded file. Okay. Better to convert this value is now it's in binary, so I'm going to convert to a decimal. So it's showing you the decimal. Also, the code that you wrote, you can see it in a plain English. It's much easier for you to read. Okay. Where is this? It's actually in the processor one. As RAM, the first one actually, not in the second option. Okay, this is the first option. This is the RAM. This is the cache. Now you are in the memory location 1. This is the first memory location, 00000. So this is a memory location first. Now your program will execute 3 lines at a time. It's going to jump every. Next will be number 3, and number 6, and number 9, and 12, something like this. It will keep on going. So let's see now. Now, how to see a current value in accumulator? This is the place will help you. The custom area. Here it will show you this is the accumulator value. Whenever the program is running line by line, you can see the value of accumulator here. And also this is binary, so better to convert that. Just right click on that radix decimal. So now the accumulator value initially it's 0 because there's no value at all. Right, now we are here. So how to run it line by line? You have to either press this button to single step at one time, so it will jump. Now the icon here, the cursor is here actually. The what do you call that? The pointer is here now. So when I press F10 or this icon, which is single step F10, so press F10 and it will jump to the next step. So just make sure that every time it jumps 3 lines. It's not jumping one by one, 3 lines at all at the same time. So now I load number 7 to the accumulator, right? So the accumulator should be 7 now, not 0. So I go to the custom again and see, oh, perfect. So accumulator is number 7. Now I go back to this. Now the pointer is here. I'm going to store that number to the memory locations. You know that because we cannot see it here. The rest of the things, even if I make it bigger, I found that it's complicated here to show. Okay, maybe we can see it like this. Fine. So it's a decimal value, right? That's why it's showing to you. So you're storing to the accumulator, and even after I store and I'm pressing F10, it come to the next line and go back and see still the accumulator is 7 because we did not change the accumulator value. We load number 7 to the accumulator and we store it to the memory location. Now we come to this level. We are still here, but we did not execute it. So the accumulator value is still 7. Go back to this and then execute one more time. So I finished already executing this line. Now the accumulator value should be 8. Go back to the custom and see. Okay, so far it's smoothly running. First is 7. I'm saving the 7. Now I load 8. I did not save it yet. So I'm going to save it. It's fine. So it's still number 8. Now I'm loading number 9. I did not do it yet. When you press F10, that will be loaded. So the accumulator should be number 9. It's here. Go to this. Then I'm storing it now. Now I loaded 3 numbers to 3 different memory locations. So how to make sure that now the currently accumulator is 9. It's okay for me. How to see where is my value? Just go to the address. Address, you remember, right? Address is 80, 81, and 82. I'm just going to the 80, 81, 82 and just slowly going. It's fine. The numbers are here, right? 80 is 7 and 81 is 8 and 82 is 9. So far what we did is perfectly all right. We load the numbers to the accumulator and we load the accumulator. We save the accumulator value to the memory. This is done. So now, so far it's fine. So what you have to do now, we have to continue editing our program. So I'm going to click again, launch program editor. Now I'm going to open the file that I saved, which is left08. I'm going to open it. Fine. So at this time, I found something like the blue color marks are gone. So what do you do? Just put it in the end and press space. It's coming back. And then, so fine. So erase the unnecessary space. I have no idea actually whether it will give you error, but anyhow, to be very clear. Fine. So now, what do we have to do? Now we have to find the biggest number. So we know that the values are already stored in a memory location. Then we have to retrieve the value from the, it's like we are storing 3 values in a 3 box. Then I open one box and take the value. And I open another box and take another value. Then we can compare it. So I'm going to take the number 7 and number 8. I'm going to compare this. Who is bigger? Number 8 is bigger. Okay, so I keep the number 8 with me. Now I will take the number 9 and compare. Who is bigger? The number 9 is bigger. So I will just leave the number 8 and take the number 9. That's the answer. This is what we have to do. So in order to do that, first we have to read the value from the address to the accumulator. So whatever we did so far, we load the numbers. We just store the numbers to the location. We keep numbers in the boxes. Now you read the boxes and keep it. So you can do one work actually at the time. So you can keep one value at a time in accumulator. So I'm going to read the first value. How to read that? Load ACC and then 0x80. So in this case, here you see store ACC to the location 80. Now I'm loading from the location 80. So I know that actually it's loading number 7. Fine. So now the technique, what to do, how to compare that. So I got one idea from my mind. I'm planning to deduct, subtract from number 7 and number 8. I'm checking it whether the value is greater than 0, or if it is a minus value, that means the second number is big. If it is not minus value, if it's a positive number, first number is big. Even 0, I can take any of them, so it's fine. So if it is positive, I take the first number. If it is negative, I take the second number. So I'm going to do a subtraction now. So how to do a subtraction now? Simply you can say subtraction. So subtract what? The second number. So where is the second number? It's in this location. So simply when I load this number, accumulator now will contain a number 7. Now when I say subtract this address, it will go and check what is the value on that address. It's taking number 8 and subtracting it. So now I know that the answer is -1, right? For the meantime, just imagine the answer is -1. So I'm going to put this mark here. That means it's a comment line. This will not execute in the program. So I'm putting // -1. I know that already. Now how to compare who is the bigger and who is smaller? We know that. I'm going to put one more space here. I will tell you two more spaces here. I'm going to tell that. Now I'm going to use the JS command. What is the JS command? JS. JS means it's like a jumping command. If the value is negative, the JF command will give you SF is equal to 1. I forget to open it in the screen actually at the commands. So what happened actually, now I'm subtracting these two numbers. Now if you subtract this number, the answer you will get is -1. Now when you get -1, the SF value means when you go and see the chart. Okay, let me open the chart as well. I hope that this is the chart. Yeah, this is the chart actually. So we can see it here like 100% big. Now I'm going to use the JS. This is the JS. So JS is always have a something is inside. After that, I will show you how. And then it's giving you if SF jump if sign SF is equal to 1. So when you subtract one value with the other one, if it is a -1, if it is a minus value, the first binary digit is 1, and if it is a plus value, it will give you 0. Based on that conditions here, so if SF is equal to 1, then it's moving the pointer actually. So we will see that. Now I'm saying here, if it is SF is equal to, this is for me, I'm writing by this information for me. If SF is equal to 1, that means it's a negative value. If it is a negative value, I take the, okay, so sorry, if SF is equal to 1, that means negative value. So when it become a negative value, it will jump to somewhere else. If it is not negative value, it will not jump. So it will continue its processing. So if it is not negative value, that means the first number is big. So I'm saying that load ACC. I'm loading that number again from the memory, which is 0x80. I'm loading this value from this location. I'm loading this one. And then I'm going to store the value, because I know that very clearly. If the first number is bigger than that one, that's a condition. If JS return subtraction of these twos become a minus, that means JF is equal to 1, SF is equal to 1. If the SF is equal to 1, it will jump. So now if the SF is equal to 0, it should not jump. That means the first number is bigger. So I'm saying load ACC equal to x80. And then here, according to the question, they said find the largest value from above three numbers and store the value in the location 83. So now I already decided, when I compare these two numbers, I already decided in this case the first number is big. So I'm going to store ACC to 0x83. I'm storing to the final location. I'm deciding because it's the first step actually. So I'm finding out A and B, I'm comparing it. Oh, A is bigger. So I'm loading the A again to the accumulator and storing it here. If it is not, I have to load accumulator from the second number, right? That means 0x81. After I load, I have to store that number, store ACC to 0x83. And now, how do I know that whether what will happen here? It's coming here and doing a subtraction, right? After the subtraction, you are continuing the line. It's not going to jump anything, right? Here is the point. That's why I give two spaces here. If the SF is equal to 1, it will jump. That means the second number is big. In that case, I have to say here to jump, I have to say how many line you have to jump. So if second number is big, I don't need to read the first number and store it again. I don't need to do this step, right? I don't need to do these two steps. So every steps will take three lines in the memory. So this will take three lines and this will take three lines. That's why I'm selling here now load accumulator number 6. That means I'm giving a small instruction to the JS. This is the instruction. This in this area load AC number 7 means I'm loading number 7 to the accumulator. Here also it's doing the same thing, but this is a special thing. I'm saying load number 6 to the accumulator, and JS knows that you are telling the JS if the SF is equal to 1, jump 6 memory location. That's the instruction. So now the accumulator value, once the cursor executed this line, the accumulator value is 6. But you are not going to save this 6 or retrieve it somewhere else. You are keeping this 6 just as an instruction to the JS, saying that if the SF value is equal to 1, that means if it is a minus digit, then jump. If it is minus, means the second number is big, so jump 6 number. So 6 number means not this is 1 and this is 2. No, only in the memory location. For example, if it is 77, it will jump 6, 78, 79, this 1, 3, 4, 5, and 6. It will jump after 6 numbers. So every line, this is the condition. So you should not include the condition. Second line and third line. So these two lines, you should jump it. Okay, you have to jump and you have to continue to work. Now, if the first number is big, so it will not jump. It will load this number 6 to the accumulator, but it will not jump. But if it is not jumping, it's saving loading number 8, this location, loading it and storing it. After that, it will overwrite. It will do this also. So I don't want this to write. I mean, only one things to run. If the big number A is bigger, I have to save it, load it, and save it. And I should not do this. So how can we solve this? This is another issue for us. And there are something called, we call it NOP. If we use NOP, what will happen here? The entire program will stop after this. But I don't want to put a NOP also, because now I only compare two numbers. I'm not comparing the third number. So I cannot use the NOP at all here. But we can use something called jump. Just simple jump. Jump. And again, I'm going to say jump number 6. So what happened now? Let's see why I put jump and what is the use of this. Simply now we are subtracting. Here is the main thing. Okay, this area is very simple for you. Main thing is you are loading first memory address to the accumulator, and you are taking the second value and then subtracting it. Now, if the value is become minus, the SF will become 1. If SF become 1, it will take this as a number of rows, number of memory locations to jump. So it will jump 6. That means it will skip this and it will skip this and it should skip also this one actually. Now I wrote this line. So it should skip these 3 lines. So it should be number 9. So if this become a negative number, it will skip load accumulator, store accumulator, and jump. So it will come here, it will continue this two work. I'm taking the second number, storing it, and it will continue. If first number is bigger, so it will not, this is meaningless. It will not do anything. It will come to this and it will do this work and it will do this work. After that, it will jump 6. I mean, it should not. I should tell them that don't do this. That's why I'm telling jump. Don't do this. Jump. This is 3 lines and this is 3 lines. So it's going to jump 6 memory location. So first steps we did it already. Now we go and do the second step now. What do you have to do the second step? The same thing. So I loaded this one, I subtracted already. Now I have to load this value, okay, and then compare it with the third option. So now I'm going to load, which should be 82, right? Or we can do something. We can load this value, which I store here, because in 83, for the meantime, I compare first two numbers and I save the value to the 83. So I know that the biggest number between this A and B, I got it here. So now I'm going to load accumulator, which is 0x83. That is the final destination, by the way. That's the final destination. I save the first, I compare first two numbers and store. Now I'm going to do a subtraction with what? The x82, the third number. So I compare first two numbers and get the answer and store it already. Now I load the biggest number between A and B and I'm subtracting with the third number, and you have to do the same comparison again. So I'm going to copy everything here, or we will I will write it is much better actually. So now I think we will be running out of space here, so I'm going to combine this. So now you subtract it already. I'm going to put the JS. Actually, we can copy it simply. I'm going to copy this area, right? And then paste it here. Now we are running out of place again. Come on. Because you cannot expand this window, by the way. It's too small. I cannot expand it. I don't know how to do that. Okay. Now we have to compare again. We are lost already. Okay. This is one step. I want to put these things to show that we finished first step and the second step. Now loading 83 to the value and subtracting with the 82, and if the SF is equal to 1, that means if the first number is smaller and the second number is bigger, now I have to change this address to which one is bigger here. If SF is equal to 1, that means it's negative. If it is negative, means the second number is bigger. So I'm loading 82 and storing it in 83. Otherwise, so the second comparison, now I'm loading 83, which is the intermediate result. I save it in 83 and I'm subtracting with 82. I'm saying that accumulate. Actually, I don't need that. I will tell you why I don't need this one, because I don't need to jump anymore. I'm saying here, if the value is negative, if the value is negative, the SF is equal to 1. If the value is negative, that means 82 is the biggest number. Okay. And then I load the 82, the address 82 to the accumulator, and I'm overwriting the storing on the address of 83. So this is already so far perfectly all right. Now, There's other conditions we forget to add that. If if it is negative, we handle it already. But if it is positive means SF. Okay, okay, there is a way to go down by page down. Okay, good. So okay, when I press page down, you can go down. When I press arrow key, I cannot go anymore. Fine. So now here I'm loading 83 again and then subtracting it, and then if the answer is negative, it should jump. Otherwise, if it is negative, it should jump. If it is positive, yeah, here, this is we have to go slow, slowly one by one. If the answer is negative, the SF is 1. That means it will jump. If it is negative, that means 82 is the bigger one. I'm loading the 82 and storing it here. If the answer is positive, the SF is equal to 0. If the answer is positive, what we have to do, we have to simply jump. I don't want to do anything because if the compared answer between A and B, and that is the one bigger than the C, I don't need to store anything. Everything is fine. If it is not bigger than C, then you have to store the C. So what I'm going to simply say here, jump. How many lines? I'm going to jump 6 lines. Why? Because if the comparison between A and B, the answer is that answer is bigger than C, I don't need to do anything because already I see already here we are storing the bigger number between A and B to this location, bigger number between A and B on this location. I'm comparing and saving it. So if that answer is bigger than C, I don't need to do anything because already my answer is the perfect location. If C is bigger, in that case, you have to do. That means if the become value, the subtracted value become minus, that is SF is equal to 1. In that case, it will load the 82, whatever is in the C, it's loading it and storing in the A3. If it is exactly a comparison between A and B is bigger, I'm just jumping it 6 numbers. So I'm not going to execute that. If the intermediate answer is bigger, I'm not going to execute. That's why I'm telling the compiler, the pointer that jump 6 line. This is equal to 3 and this is equal to 3 is jumping it. At last, it's much better to put a not because I don't want to run anything anymore. So this is the thing. I am going to put also a small break here. I'm storing number. See, when I go up, it's not going. You have to press the page up. Okay. So first I'm storing 3 numbers here. I don't, after 3 numbers, storing 3 numbers, I put a small break. This is first thing. And then second option is I'm loading a number and subtracting it. And then I'm giving an instruction to them, jump 9 lines if SF is equal to 1. That means if it is a negative, right, I'm telling them to jump 9 numbers, 9 memory locations. So it will jump this line and this line and this line. And it will execute this. If it is not, it will do these options. First option, this one, and it will do the second one, and after that it will jump 6 line because if I do these two, I don't need to repeat this. So it's jumping. After that, I'm comparing the second comparison. Let me put also one space here. I'm doing a second comparison, which is this. I'm loading the answer that I wrote to the memory. I'm bringing it back and subtracting with the C, which is 82, location 82. And I'm again doing the same checking here. Okay, I'm doing the same checking here, and I forget something here. Should say load accumulator number 3. Why number 3? Because if SF is equal to 1, that means if it is a negative number, I should skip this, right? That's why I put load accumulator number 3. I should skip this one because otherwise it will jump again. It will not do any of this. So if it is negative number, I'm telling them forget about this line, that is load ACC number 3 memory location. I'm jumping it, I'm doing this, and I'm doing that. If it is a positive number, if SF is equal to 0, which is positive number. In that case, I'm just jumping 6 and I don't want to do this and jumping and going to the north. So this is so far perfectly all right. Let's check it. I'm going to save it now, overwrite it. I'm checking it now. I'm building it. I got a build succeeded, 0 errors and 0 warning. Fine. So better, I feel that is much better to close it and open it again. And my files are here. I open the Sepsim again, make it maximize and go simulation, initialize, and then change to IL and then load program number 8 and let's see this one and convert this to decimal and go to the custom and right click and convert to decimal. Let's run now. Let's go one by one. Okay, so until here. So, okay. Now I'm going to press now F10. F10 loading accumulator. So we know that we will see here. Okay, I'm loading now. I'm storing it and loading number 8 and storing number 8 and loading number 9, storing number 9. Now I'm going to compare that. So just remember what you write. I'm loading number 7 to the accumulator and subtracting a 2 value, but this is an intermediate value. I think I do not know why. And when you subtract it, 7, I'm loading number 9 and then uh, what's happening here, 7, 8, 9. Let me see what's going on here. So where are we now? We are let's run it. Let's run all of them. So now it's come to the knob. That means it's the end. How to see our values now? Just go back down and then where is the number? So here. Now 80 is 7, 81 is 8, 82 is 9. So the biggest one is 9. So it's perfectly all right. Anyhow, some intermediate values I still have no very good knowledge on this one, but anyhow the answer is right. So now let's try by uh, changing the numbers. I'm going to go and open it again and let 08 7 8 9. So I'm going to put 7 9 and 8. So this time it should give me 9 also, right? I'm going to save it now, save it back, check it and build it, close it, and then okay, instead of 9 we change a different number because we do not know when the old program is running. So I'm going to put 5 and 4 and 3 for example. Save it, check it, build it. So it's a long program and I'm loading this and restart this. I'm restarting it. Go to the top and make sure that the cursor is here. It's not there. Still not there. So in this situation, it's much better to close the Sepsim and open it again. Sometimes, so initialize it again and IL load program with 08 and change it to decimal. So, see the 5, 4, and 3 are updated before it's not updated. Okay, let's execute now. So the biggest number among this should be 5. And then I'm executing it by pressing F10 several times until I meet NOP. Okay, so we are already in the NOP. Where are we now? Okay, we are in the NOP now. So just go down and see your values. Okay. 8 is 5 and 4 and 3 and it's identifying the biggest number. So first the biggest number in the last one, the second option now the biggest number in the first one. So now we will do one more test by changing the biggest number to the middle one. So I'm going to put number 22 and this is 11 and this is let's say how much, 12. Okay, save it, check it, build it, closing it, and I prefer to close and open again. Simulation initialize IL and then load the program to 8 and make sure that convert it to decimal and then 11, 22, and 12. So you know that the answer should be 12, right? So I'm going to execute it now. F10 and F10, 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 F10. We don't need to wait much longer to complete. Just press F10 and at one point it will stop and it will not move the list, the progress here. So it's not moving. Just go down and see. Okay, we are in the knob now. I go down and see 11, 22, 12. So the biggest is 22. So I hope that it worked. And then this is the code. This is the compiled file, by the way. And this is your code. So that's it. Very simple code. First storing the data, loading and storing it, and comparing the A with the B, and storing the biggest number. After that, load the biggest number that you get the intermediate value, and load subtract with the C, and do the same thing what we did here. But the number of lines that you are telling them to jump is differ here because we are not doing many things high. So very simple code. I hope that it will help you for your Viva. Thank you so much for watching.